So welcome back. After that first video on the DC58 Dyson vacuum, this second video is going to focus on how to get it back working. And I did spend hours and hours looking into this battery pack. And I did ask which direction people would like to go to comment, kind of vote down below in the comments. Would people rather see it be with a lot more time focused on repairing the original battery with some kind of known issues, or would you rather see it Frankenstein? You know, would you rather see me run it off of a different battery pack? For me, it was, you know, my M18 stuff's what I have a lot of different sizes of and things of that nature. And we mentioned even though a 24 volt battery like a Cobalt 24 volt or the new Flex stuff that's coming out 24 volt would even be a better fit. I kind of got mixed comments about it. A couple definitely wanted to go a little further with this. Most said Frankenstein it, you know. We like to see it being made to run off something else. So I felt like the best thing to do was just touch on this briefly, and then we'll get right into putting the M18 running the vacuum. And the reason I didn't want to spend a lot of time on this is I actually didn't get very, very far. And I didn't realize that so many people had attempted it. When I first searched for DC58 and repairs and things, I didn't really see anybody having any success. And even though I still didn't see a lot of success, I actually noticed some people, and some people commented on the first video that they had run into similar issues trying to resell these. Whenever you take the battery power loose, like I've done here temporarily, well, I can just take the 24 volts off, breaking the circuit between the 5th and 6th cell here. And I can put it back. I just have it clipped where I can just temporarily clip it back. And of course, cycling the power didn't help. And obviously, after talking with other people, it probably made it worse as far as I thought recycling a microcontroller like a reset would fix it. But I'll have a little bit of information up here as I went through troubleshooting on the PIC16. We also have our battery management chip here. This battery management chip was very interesting, and I spent a lot of time, as I'll show on the screen here, how it's laid out. The data sheet was actually very helpful. It's an ISL 94208, but I went through every single pin and looking at the typical diagrams we see here. I tried to look at this thing and figure it out, and as far as I can tell, everything is good with the way it sees the cell, the temperature, the way it does the cell balancing and monitors. And we also see we have a lot of different outputs from this chip, including CFET and DFET, which one's like discharge FET and one's like charging FET. So we do know that something with this is not working correctly. And we also know that the microcontroller probably has something to do with it. So as mentioned before, and as a couple of viewers mentioned on my first video, they realized too that the microcontroller must be programmed to the point where it will not let you use this battery again if any of the cells go below a certain value. So of course our PIC is a programmable microcontroller, and even this battery management chip is programmable and it's addressable, and it's through the I2C protocol. So if you have time to look up the battery management chip, it's actually got 36 pages. And it's very interesting because it talks about the registers and how you can set different registers in there to do certain things, including like the wake up and the monitoring. And yes, there's ways to make this chip not just automatically reset. So without going further in the programming of this little battery management analog front end chip, or the PIC16, and it's probably over my head anyway, and it really just isn't worth it, right? I mean, as interested as I can be into just knowing how things work and how we can fix them, this is one of those things that's probably just simply not worth the time. I just hate that there's so many of them with the same issue. But I went through every single component and I cannot find no component bad. Even the NTC and the microcontroller and the management chip seems to be okay. But I do believe it is in the program that if any of these cells go too low, that it will never allow the battery pack to be usable again without reprogramming or reset one of the bits in the bit register in one of those two chips. So even though it wouldn't have been a bad job to put all this back together, it actually straightened all up pretty good as far as the housing goes. One thing I won't leave this without saying is there is a workaround to it if you really wanted to get to that level, and that's this MOSFET right here. So we actually have our source and our drain. Let me get a better way to point here. So we have our negative coming up to our source pins here, these middle pins, and I believe it's 1 through 3. And then our drain goes to our output on the battery terminal. And I do believe that pin 4 is our gate. So there is a way that we can set it up like we're going to do in a few minutes. You'll see in the video how we're going to set up the trigger to work a switch. We could truly still leave this hooked up and work that in and make that switch activate this MOSFET. Just have to ignore the battery blinking and stuff like that. But the Dyson will get to a certain voltage, which you'll see it'll start blinking and it'll finally shut off as well. So maybe not the best battery protection, but at this point, I mean, you're just trying to salvage the battery anyway, right? I mean, you don't really care, but you just want to be safe with it. Of course, recharging it, you have to take care, as we mentioned on this channel many a times, you have to charge it either individually on the cell to keep it balanced, or while you're going across it with your 24 volts. Always monitor and make sure they're staying balanced. But just to demonstrate that, you know, this is my bad pack that I had no luck with. I just got some LED strips here that's rated for right at 24 volts. As you can see there, I have an output. So I did that instead of just simply showing you the voltage. Many of you may know, and if you don't know, I want to make sure you do know that you'll read your main output voltage or real close to it across these, even with the MOSFET not gated, because it'll just read until you put a load across it, which can be confusing. Some people commented, you know, that they read 24 volts across it and it would still get the blinking light and wouldn't activate, because it will not activate that MOSFET. So what I've done is I've turned on the MOSFET by putting a positive voltage on the gate. And of course you got to go to negative voltage on the gate to get it the deactivator cut off. So it needs to be kind of a voltage divider there if you wanted to run that. But that's enough about the battery pack. Next, I want to show out in the garage working on the Dyson DC58 and trying to put the M18 battery to it. Okay guys, so back now in one of my garage workbenches and got the Dyson DC58. Going to try to come up with a way to make a switch. And going to take this M18 battery connector here and use it to our advantage with a 1.5 or either a 2 amp hour battery probably, just to keep the weight. Of course, if you want the long run time, you could always switch over to the 4 or 5, or I guess even large if you wanted to carry it. But got this really nice adapter here. I like the way that the prongs were. I like the way that it's a PA6 GF30 made in USA. So this is going to be a molded, so you can see the ejector marks around the peripheral here and inside. And I he'd rather do this than 3D print it myself, so I got to come up with a way to mount this and also mount a switch. So I come up with this switch here that I have a spare of that's used in a good many power tools. I know I've seen it in some jigsaws and things of that nature. So this is a 5 amp rated switch, but it's an AC rated switch. So I might have to see if I can find something better long term. But I do want the same size because I can mount this at an angle in here. I want to shoot for something about like that. And I don't want to mount this very rigid, so I was going to bend a little piece of thin aluminum. And then I got to thinking about it. I'd rather it be, since this switch don't have a lot of stroke to it, I want to have a little bit of forgiveness built in with the lever. If you squeeze the trigger real hard, I want to have it mounted on something forgiving. So I have a piece of this polypropylene that I had saved just for something like this, matter of fact, just for a little project. And I've kind of cut out a rough shape here, almost like a guitar pick shape. And I'm going to continue to shape this. All right, back now, I did go with a thinner piece of the same shape. I want to mount it like so. So I've already drilled my holes and found these screws that fit into the housing of the switch pretty well. And I scribed me a mark and drilled my holes. So hopefully this will work out pretty well. Just go in here like this. I'm going to mount back with that 1 T8 screw that from the factory goes into the switch mechanism here. So that was my idea there. So I just got to solder onto my switch with my wires and come down and hit the plus, and I'm going to switch the minus just like the original did. So just going to tie this together and we'll figure it out. You probably hear the air conditioners come on now. It's a little bit noisy, but it is a little bit warm, and after a gentle rain, the same rain that stopped the Masters here in Augusta, Georgia today. Not that I was invited, but hey, it is beautiful there. Just thought that I would share that at this time in the video. That's exactly what's going on, is the Masters tournament in Augusta, Georgia. I'm pretty happy with that, so I'm just going to take it back off and solder the wires onto it, and we'll be right back after we get it back installed. So back now on my workbench, I'm just going to solder up the wire and attach it to this positive here up at the top. That way I'll leave this alone. I can modify this how we want, really. Just take the wires off, make a different switch. But I'm going to kind of leave it so I can even put the original setup back in it if I ever want to or desire to. So a little bit more challenging to do it that way, but that's what I'm going to try to do. I have scratched up this surface and cleaned it up, and I'm going to put some rosin flux on here and see if it'll take to the solder. Looks like it is, and if that's the case, I'll be able to easily remove this if I ever decide to, so that'll be great. Put some heat shrink on here. I'll put some on here as well since we're not using the stab. Like so. Now do the same thing to the negative side, and we'll go to the switch. We'll be right back. We're going to use our common and our normally open. So again, I got the negative side here roughed up like we did the positive. Go ahead and tin this wire as well. Go ahead and make sure I solder a take here and get us a small puddle forming. Let's just give this a quick preliminary test before we try to put all this together. All right, I like it. So I definitely planned on using the nice tapered head screws I had to fit the holes made for the tapered head. But unfortunately, there was not a good way up top to make it nice and clean. So I'm going to go with the the round head Phillips I have and catch the bottom with a nut. I hate it don't look as clean, but I got plenty of room there, so I don't have to have it flush, so I'm gonna sacrifice that to be a little bit cleaner where your pinky goes, you know what I mean? Where your hand touches. If you're left-handed or right-handed, it will matter, so I'm gonna change that up a bit. And even though these two screws hold this very, very stable, I am gonna come back after the video and I'm gonna put a strap across here, whether plastic or aluminum, and I'm gonna make use of them two holes to clamp this down and give it extra support. Probably don't need it with a small battery, but just in case we did throw a big battery in there, it might need a little extra support. So I'm gonna go ahead and put my cover back on this time. The little end cap. And there we go. That feels pretty nice, actually. And one thing I would probably do different, I have to desolder to do that, but I probably, since I have so much room under here in between the battery and that opening, I probably would have simply brought my wires out through those two holes. I wouldn't even have to drill any. Just brought them out through there and routed them around. So they wouldn't have been in the way right here at the very end. I didn't think about that. That's one thing I would have done just a little bit differently. And may do that, but not on video. So one thing I know I have to do design-wise is that 5 amp AC rated switch is not gonna probably hold up. This thing actually pulls up to 10 amps. It's actually a beast, so I'm definitely overrating that switch. And I may have to find me a relay. This relay right here may not have room in there. This is the relay that I mentioned in a Ryobi airstrike video that I like. This one just hadn't come in yet, but I have used these and liked them a lot. This one's rated for 25 amps, so it's a 24 volt coil. So that's a thought anyway. We'll just dump that out so we can vacuum it up, test it again. So even though I like the way this push button worked out tremendously well, I realize in low, we're pulling about 5 or 6 amps. We switch to high, we're pulling up to 3 times that much and always more than twice that much. So we run anywhere from around 14, 15 up to 18 amps when we switch over to high. So this switch is absolutely not gonna hold up. This is on low. High may actually pull more than my meter wants. Yeah, we'll call it 15 amps before I blow a 10 amp fuse here. So as bad as I hated, I had to pull this little design out. I didn't have any relay rated high enough that would fit in that small spot. And even though I don't like it, I'm gonna have to rig up this bigger switch. So I had this as a backup. Hopefully you can see the writing on here. It's hard to read. It's a DW30. This is a 30 amp up to 60 volt DC rated switch. So it's definitely rated high enough. It's just going to take up a lot more room. I've already bent this very gradually because my very first bend, if you can tell that, I broke it. I tried to bend it into like a 45 lever on the tip, and it broke, so I had to build a radius into it, just bending a little bit at a time. Bend it just ever so slightly in probably 5 or 6 different spots until I got a little radius, because I'm going to have to slide this thing a little bit different angle of approach here. The switch is physically larger, and once I get it in here, I should be able to work it something like so. Just for testing purposes for the video, I'm just going to bring in some foam I'm just going to get this positioned the way I want it, and we'll be right back. Okay, so just for testing purposes, I cut a few different size pieces of foam at different like wedges or angles. That way I'll know how I need to position it more as I test it. I'm going to go ahead and put this back together though, that way we'll know how everything's fitting together as we test it. I did make me a little bracket like I was talking about across the front, like so. So it does work very well. The takeaways from this build, I mean, it was tremendously fun to take the Dyson and adapt the M18 battery to it. It worked out even better than I thought it would. The positives is I have plenty of batteries for it, and now for about 40 bucks that I pay for a non-working unit, I actually got at least a light duty Dyson. I can throw an M18 pack in and go out and vacuum up my workbench, vacuum out my truck if I want to. So altogether, I'm pretty happy with it. So a couple of the negative or drawbacks to it, of course, being 20 volts maximum output instead of 24. Obviously, we're not going to get as much run time before we start getting our blue blinking light. And it pulls the voltage down to the point that to run this on the max setting for any length of time, we actually do have to go up to a 4 or 5 amp hour battery, just so the voltage doesn't drop immediately. But with that being said, it does work. But it starts blinking on max pretty soon with a 1.5 or 2 amp hour battery. So that was really to be expected. So we did have to mount this so our canister would still be okay and miss and come off okay. A really fun build. So ultimately, is it better just to buy a replacement battery for anywhere from $28 to $35? Probably. Would that be near as fun? Absolutely not. Hope you really liked this video, looking inside of this Dyson 58 in the previous video, and as well as this one, making the M18 battery fitted. Well, if you did like the video, please like, share, subscribe, and thanks for watching. And I'll also have a link in the description for a replacement battery, like an Amazon link. It was helpful. Any links y'all do click on do help support the channel, and I greatly appreciate it. Thanks again for watching.